The James Webb Space Telescope, humanity's most sophisticated eye in space, recently detected a staggering cosmic event that has sent ripples of excitement and curiosity through the scientific community. Far beyond the familiar glow of Earth's moon and the orbits of Mars and Jupiter, at the cold edges of the solar system, something colossal slammed into Neptune. For the first time in recorded history, a space observatory has captured the unmistakable aftermath of a massive collision on the surface of one of our solar system's outermost giants. The implications of this discovery stretch far beyond Neptune itself, forcing a re-examination of the dynamic and sometimes violent nature of planetary systems. Before we start, smash the like and subscribe buttons for more updates. The detection began with an anomaly. The James Webb Space Telescope was conducting a scheduled observation of Neptune's atmospheric activity, part of a long-term mission to study the ice giant's seasonal changes. At first, the data seemed confusing. Bright spots appeared unexpectedly along the planet's surface, bright, chaotic patterns of thermal and visual disruption, where normally there would be the smooth swirling bands of its methane-rich atmosphere. Webb's infrared instruments revealed abrupt spikes in heat signatures concentrated around a specific region of Neptune's atmosphere. These were not minor fluctuations. The scales involved were enormous, suggesting an energy release that could only be explained by a monumental impact. Drawing from the immense detail Webb can provide, researchers quickly pieced together what had occurred. A massive celestial object, possibly a rogue asteroid or even a minor dwarf planet that had strayed from its orbit, collided head-on with Neptune. Estimates based on the infrared analysis suggested that the impacting body could have been tens of kilometers across, traveling at velocities that defy everyday comprehension. At such speeds, the energy of the collision would rival the combined arsenal of the world's most powerful nuclear weapons, millions of times over. The force unleashed by this encounter was enough to pierce Neptune's upper atmosphere, momentarily disrupting the planet's deep-layered weather systems and sending shock waves across its ethereal blue clouds. This was not just a simple event of debris meeting atmosphere. It was an astronomical ballet of cause and effect that reached into the very identity of Neptune's existence. The turbulence visible after the impact revealed not only the layers of Neptune's atmosphere in unprecedented detail, but also hinted at the presence of deeper, hidden processes at work within the planet's interior. Scientists marveled at the sudden upwelling of material from lower atmospheric layers, thrust into visibility by the violent disruption. This rare glimpse beneath Neptune's typically inscrutable exterior offered an invaluable opportunity to study its chemical makeup, which until now had remained largely speculative. Beyond the awe of the collision itself, the event raised significant questions about the stability of the outer solar system. It had long been assumed that the regions around Neptune and Uranus were relatively quiet, disturbed only by slow gradual changes over millions of years. The detection of such a massive impact suggests otherwise, that even in the cold, distant reaches of the sun's gravitational influence, dynamic and cataclysmic events still unfold. Webb's discovery implies that the Kuiper Belt, the massive ring of icy bodies beyond Neptune, may be far more active and chaotic than previously thought. The notion that large objects could be dislodged from the belt and hurled inward at high speeds opens a Pandora's box of possibilities regarding planetary defense and the ongoing evolution of the solar system. The sheer size of the object that collided with Neptune hints at forces at play far beyond the planet itself. Perhaps gravitational interactions with unknown massive bodies lurking at the edges of the solar system, the theorized Planet 9, or even rogue stars passing nearby, could occasionally disturb the delicate balance, sending massive objects hurtling inward. If such disturbances are more common than previously suspected, it means that all planets, including Earth, are periodically exposed to catastrophic impacts from deep space, though at vastly differing timescales. Neptune's magnetic field, already one of the most unusual in the solar system due to its extreme tilt and offset center, may have also been affected. Early readings post-collision indicated temporary disruptions in the planet's magnetic environment, offering another line of inquiry for scientists eager to understand how external forces can shape planetary magnetospheres, a subject of critical importance for understanding planetary habitability in exoplanetary systems. Moreover, the collision on Neptune presents a new opportunity to rethink the long-term geological and atmospheric evolution of ice giants. If impacts of this magnitude occur even once every few million years, they could be a major driver of atmospheric chemistry, internal heat distribution, and even rotational dynamics. Perhaps features observed on Uranus and Neptune, previously attributed to slow internal processes, are in part the scars of ancient collisions that, like this one, dramatically reshape their histories. James Webb's ability to detect the collision and observe its immediate aftermath with such clarity marks a historic leap in humanity's ability to monitor and understand the solar system. Previous telescopes would likely have missed such an event entirely, or only captured its fading remnants. Webb's sensitivity allowed scientists to observe thermal and chemical changes in real time, to chart the dispersal of debris clouds, and to model the energy propagation through Neptune's dense atmosphere. This collision also rekindled a sense of cosmic vulnerability. For all the technological and scientific advances humanity has achieved, this sudden violence unfolding on a distant planet reminds us that space remains an unpredictable, dynamic frontier. The same processes that shaped the early solar system, chaotic collisions, gravitational perturbations, and violent transformations, are still at work today. Earth's relative stability may be more of a fragile gift than a guaranteed constant, a realization that adds urgency to ongoing efforts to understand and perhaps one day prevent catastrophic impacts closer to home. There is a broader philosophical dimension to consider as well. Events like this impact are stark reminders that planets, stars, and entire systems are not permanent fixtures but actors in an ever-changing cosmic play over vast timescales. Planets can be shattered, atmospheres stripped away, orbits changed beyond recognition. Neptune's collision demonstrates that even the mightiest planetary bodies are subject to the whims of fate, mere moments away from dramatic transformation by forces larger and older than humanity itself. The scientific world now finds itself at the precipice of a new era of discovery. Driven by the capabilities of the James Webb Space Telescope and spurred by the questions raised by this collision, there will be countless follow-up observations, theoretical papers, and heated debates as researchers scramble to understand exactly what happened, how often it happens, and what it means for the broader narrative of the solar system. Questions about the origin of the impactor, its composition, and its journey through the solar system will fuel years of inquiry, potentially unlocking secrets about the birth and ongoing life cycle of the planetary family to which Earth belongs. In the weeks following the detection, simulations were run using supercomputers to reconstruct the collision. These simulations suggested that the object likely fragmented upon impact, sending high-velocity shards deep into Neptune's interior, perhaps even altering the planet's internal structure in minor but measurable ways. If true, then every layer of Neptune's atmospheric and magnetic personality may now bear the fingerprints of this violent encounter, encoding the story of the impact in ways that future generations of astronomers will continue to unravel. Continued in next message.